Have you ever wondered why the 13.8 billion-year-old universe? But it has reached an observable scale of 93 billion light-years. In theory, due to the limitations of the speed of light, no matter how advanced the instruments we use, they can only observe the universe up to 13.8 billion light-years away. But according to the most influential Big Bang theory in modern cosmology, our universe is in a state of accelerated expansion beyond the speed of light. So does this violate the existing laws of physics? Because according to Einstein's theory of relativity, no object with mass can move faster than the speed of light. But why is the universe expanding faster than the speed of light? More than 100 years ago, scientists agreed that the universe is stable and static. Until the early 1920s, astronomer Edwin Hubble was observing the Great Nebula in Andromeda with the world's largest reflecting telescope at the time, finding him at a distance far greater than the diameter of the Milky Way. That means he's not even a nebula in the Milky Way. It's a separate galaxy. That means there are other galaxies outside the Milky Way. Before that, it's widely believed that the Milky Way is the entire universe. This was followed by several years of hard work. By 1929, Hubble had obtained spectra of more than 40 extranuclear galaxies. It was found that all these spectra exhibit a generalized spectral redshift phenomenon. The redshift phenomenon is a type of Doppler shift. The color change is due to the change in the frequency of light waves. For example, when a star moves toward us, the spectral lines of light will then move in the blue direction. And if the star is moving away from us, the spectral lines of the light are shifted in the red direction. The redshift phenomenon suggests that distant galaxies are moving away from us, and it goes even further to discover that the recession rate of galaxies proportional to their distance from the Earth. In other words, the farther away the galaxies are, the faster you get away from it. This relationship is known as Hubble's law. It shows that our universe is in a constant state of expansion. Actually, back in 1915, Einstein's proposed gravitational field equations then deduced a dynamic universe. That means the universe is expanding or contracting. But Einstein, in order not to destroy the beautiful finite unbounded static model of the universe, so a cosmological constant was introduced, so that the equation can be solved for a static universe. Yet it was this constant that cost him a major scientific prediction. Hubble's discovery became the most direct evidence for the theory of an expanding universe. Einstein is said to have regretted it when he learned of it, and admitted that eliciting the cosmological constant was the biggest mistake of his life. Hubble's discovery refreshes mankind's knowledge of the universe, and established a new concept of the large-scale universe. In honor of Hubble's contributions to modern cosmology, people will be the first optical telescope to sit above the atmosphere, named the Hubble telescope after him. Since the universe is expanding, so in the distant past, the universe must have had a beginning, because backtracking through time, it just gets smaller and smaller. Eventually, it will reach an infinitesimal point. Scientists call it the singularity. Everything in our universe, including space-time matter, it all stems from this infinitesimal starting point. And the process of the evolution of the universe from the beginning is known to science as the Big Bang. The so-called Big Bang is just a metaphor. It's not the kind of explosion that propagates from a defined point in all directions. Rather, it's an equal proportional expansion of the universe as a whole. From the 1990s, there were two separate research teams utilizing the most advanced equipment in the world at the time. A systematic study of the rate of expansion of the universe by observing the redshift phenomenon of Type 1a supernovae. To everyone's surprise, their findings suggest that not only is the rate of expansion of the universe not decreasing, instead, it's accelerating. And for more than 100 years before that, most scientists, including Einstein and Hawking, agree that the expansion of the universe will gradually slow down and stop under the influence of gravity, and start contracting. Eventually, we'll go back to the beginning. This process is called the Great Collapse of the universe. However, the latest findings show that the universe is expanding faster than the speed of light. Panorama of the cosmic microwave background radiation according to the 2013 Planck satellite release. The latest value of Hubble's constant was measured, that is, at each additional 3 million light-years of distance. The speed of galaxies moving away from Earth will increase by 67.8 plus or minus 0.77 kilometers per second. Hubble constant and microwave background radiation based on the cosmic expansion rate. It is then possible to calculate the age of the universe as 137.99 plus or minus 0.21 billion years. So the light that would have taken 13.8 billion years to reach the Earth, due to the expansion of space, it widens the distance the light travels. The expansion velocity of space is a superposition of velocities centered on the observation point. Let's say it's centered on the Earth. The farther away from us a galaxy is, the faster it recedes. Galaxies 46 billion light-years away are moving away faster than the speed of light. The process is like the surface of a balloon being blown up. All galactic matter is the equivalent of stars on the surface of a balloon. These points will move away from each other as the balloon continues to grow in size, but the points themselves are not in motion. So there's no contradiction between the superluminal expansion of space and special relativity. And we center this observer. A sphere of space with a radius of about 46 billion light-years is called the observable universe. And light from outside the observable universe will never reach Earth. If the universe keeps expanding, one day all the galaxies will be far away from us. There will be nothing but dark space around the galaxy, and mankind will be trapped in the galaxy forever. And the ultimate end of the universe has the potential for a terrifying great tearing apart. After an inordinately long time, the expansion of the universe will reach its limit. All celestial bodies bound together by gravity will be stripped and split apart. Ultimately, all matter in the universe, even a tiny atomic nucleus, will be completely torn apart, and that may be the ultimate fate of the universe. While all of this is just a speculation based on existing theories, but whatever the ultimate fate of the universe may be, since humans were born in the universe and learned to think, then curiosity must drive us to keep searching for the truth of the universe.